You're watching a play, spotlights, actors, the whole deal. And the spotlight's on the star, a galaxy, doing a soliloquy, or whatever stars like to do in their free time. The audience watches, all eyes on the stage, but no one notices the stagehands behind the curtains. They're struggling with ropes, wires, and no shortage of splinters. They're invisible, crucial, and possibly exhausted. That is dark matter and dark energy. Dark matter and dark energy are the behind-the-scenes crew, influencing the entire universe with no fanfare. Dark matter is the quiet gravitational grip keeping everything from spinning into chaos, while dark energy is doing the opposite. It's pushing apart the universe's boundaries. And together, dark energy and dark matter rule 95% of the universe, which leaves us with a paltry 5% of things we can't see, touch, and complain about. But what exactly are they? How do we know they're even there if we can't see them? And more importantly, how do they keep all of that under control? Let's start with dark matter, which has been messing with astronomers' heads since the 1930s. Enter Fritz Zwicky, an astronomer studying a cluster of galaxies called the Coma Cluster. He notices something odd, like very odd. These galaxies are whizzing around so fast they should be flying off into deep space, but they're not, which means something invisible is holding them together. Zwicky, in the grand tradition of scientists never overcomplicating things, calls it dark matter. Essentially, dark matter doesn't emit, absorb, or even give light a passing nod. The only way we know it's there is through its gravitational effects. Fast forward to now. We've got projects like the Large Hadron Collider at CERN, smashing particles together at absurd speeds, hoping to catch a little glimpse of something called WIMPs, weakly interacting massive particles. These are hypothetical particles that might just be dark matter in the flesh, or whatever dark matter ends up being made of. But the hunt continues. I mean, we've built whole underground laboratories for this. If dark matter is real, it's gonna have a pretty impressive reveal. Next up, dark energy, which, spoiler alert, is even weirder than dark matter. In 1998, astronomers studying distant supernovae noticed that the universe wasn't just expanding, it was speeding up. This made no sense. Gravity's supposed to slow things down over time. But here the universe was, expanding with all the confidence in the world. Enter dark energy, a mysterious force that's somehow responsible for this runaway cosmic growth. Some theories say that dark energy might just be a property of space itself. Others think it might be a whole new kind of field. And yet others wonder if the universe just has some commitment issues. Here's the kicker. Dark matter and dark energy don't just confuse scientists. They actively mess with the laws of physics. The Standard Model, which is our best attempt at explaining everything, says all particles and forces are accounted for. But dark matter and dark energy don't fit this model. Like finding out halfway through Monopoly that someone's been hoarding all the $500 bills. This has led to some very awkward questions, like, what if everything we've ever known is only 5% of the story? If dark matter particles are real, they don't interact with electromagnetism or anything ever at all. While dark energy acts like a property of space itself, so what even is it? To answer these cosmic riddles, scientists have launched some seriously impressive and expensive projects. The Dark Energy Survey in Chile maps hundreds of millions of galaxies, aiming to figure out just a little lick of how dark energy is really writing the rules of cosmic structure. Think of it as Google Maps for the universe, only we're mapping places we didn't know existed with forces we can't even see. Meanwhile, over in sunny South Dakota, the Lex Zeppelin experiment, deep underground for no reason except that dark matter particles are kinda shy guys, is searching for the rarest of interactions between dark matter and normal matter. Scientists are eagerly waiting for any at all sign of movement. So, where does this leave us? Well, with more questions than when we started, of course. Dark matter and dark energy might mean that we need a completely new set of laws for physics. Yay. The Vera C. Rubin Observatory, for example, is coming online soon, and it might finally give us some answers, or possibly a pat on the shoulder and a shrug. In the meantime, dark matter and dark energy keep on doing their thing, reminding us that we don't know nearly as much as we'd like to think we do. But hey, isn't that the fun of it all? We'll keep exploring, we'll keep asking questions, and maybe one day, when we least expect it, these two shadowy forces will decide to spill their cosmic secrets. Until then, they're the universe's longest running mysteries, and we're just lucky to have some front row seats.